You've probably heard the argument from some very smart physicists, right? That our universe is just, well, it's too big, too complex, and frankly, too weird to ever be a computer simulation. And it sounds like a pretty solid, definitive answer. But what if that entire argument is built on one single massive and unexamined assumption? Okay, let's dive into this.
So this is the heart of the problem. The idea of simulating every single subatomic particle, from the very beginning of time all the way to now, that's a computational problem on a scale that's hard to even wrap your head around. So is it really an open and shut case? Is it really impossible?
So here's our game plan. First, we're going to tackle that impossibility argument head on. Then, we'll pull back the curtain on the hidden assumption it all relies on. From there, we'll explore a totally different idea. What if consciousness itself is the computer? And what if it's using an incredible shortcut to render reality? And finally, we'll see how this whole model stacks up against some of the other big theories out there. All right, so first up, let's get a really clear picture of the mainstream objection. Why are so many brilliant scientists so convinced that this reality couldn't possibly be some kind of simulation?
It really boils down to two huge problems. First, just the sheer scale of it all. This bottom-up approach, where you'd have to calculate every single particle interaction, it's an outrageously, impossibly large task. Second, you've got the built-in weirdness of quantum physics. Think about non-local entanglement. This idea that two particles can be linked and affect each other instantly no matter how much space is between them. That kind of spooky action at a distance just doesn't seem to fit with the neat step-by-step logic of a normal computer.
Okay, but this is where it gets really interesting. That entire argument, it all hangs on one single unspoken idea, the assumption of materialism. And this, right here, is where the whole case against simulation starts to look a little bit shaky.
And this fantastic quote from physicist Tom Campbell just nails it. He basically says, yeah, you're absolutely right. It is impossible. If you assume the computer doing all the work is a physical machine, like the ones we build, sitting somewhere inside our own physical reality. But what if that one core assumption is just wrong?
And this really makes the difference crystal clear. The materialist view imagines some kind of physical supercomputer, maybe in another dimension, just grinding away, simulating our universe particle by particle. But Campbell's view suggests something totally different, a non-physical computer that doesn't brute force anything. It runs on probability, and it exists completely outside our reality in a place he and others just call other.
So if the computer isn't some physical box with circuits and wires, then what is it? Well, this is where the idea gets really mind-bending. The theory suggests that the computer itself, the fundamental source of our reality, is actually consciousness.
Let's put a name to this. The Larger Consciousness System, or LCS. Now don't think of it as a person or some kind of god. Think of it more like a vast, fundamental information system. And because it's a digital information system at its very core, its native language is logic and quantity. In other words, math.
And this is such a key point. For you and me, advanced calculus can be really tough. But for a digital system, almost all complex math can be boiled down to incredibly fast, incredibly simple addition. Multiplication is just adding over and over. Calculus, you can solve that with numerical methods that are, you guessed it, just more addition. So for a system like the LCS, computing the mathematical rules of our universe isn't some heavy lift. It's just what it does. It's speaking its native tongue.
Okay, so even if it's a whiz at math, how does it get around that massive problem of scale we talked about? The answer is, it cheats. It doesn't use brute force. It uses a much more elegant solution, a shortcut based entirely on probability. Let's see how that would work.
Now, to get our heads around this, we don't need to dive into quantum mechanics. We can use a simple 19th century canon. See, the system doesn't need to calculate every single molecule of gunpowder exploding, or the air resistance, or the spin of the Earth. It just needs to know where that cannonball is likely to land.
So here's how it would go. First, the LCS, since it's already rendering the cannon in the first place, has all the data, so it can create a perfect functional model of it. Second, it can run that model millions, maybe billions of times, in its own non-physical space just to see what happens. Third, from all that data, it generates a set of probability distributions for every possible outcome. So now, when someone in our virtual reality fires that cannon, the system doesn't have to recalculate a single thing. It just takes a random draw from its pre-calculated probability data, and poof, the cannonball materializes exactly where the probabilities say it should.
And that right there, that's the genius of this model. It simulates the function, not the substance. It's incredibly efficient. It's scalable. It's not about rendering the entire world from the bottom up all at once. It's about rendering what's needed when it's needed, based on the most probable outcome. So, how does this idea of a reality built on probability stack up against the other big theories trying to explain the universe? Well, let's compare it to one of the most famous interpretations of quantum mechanics. You've probably heard of the many worlds interpretation. It tries to solve all the quantum weirdness by suggesting that every single time a quantum measurement could have more than one outcome, the entire universe splits. Every single possible outcome actually happens, but each one unfolds in its own brand new, completely physical universe. Now, the consequence of this theory is just staggering. It would require the creation of trillions of quadrillions of new physical universes every single second. As a solution, it's what you might call a little inelegant. It creates way more paradoxes than it solves, like, for instance, where's all the energy for these new universes coming from?
And this just lays the contrast bare. Instead of spawning an infinite number of clunky physical realities just to account for every possibility, a consciousness-based system can hold all of those possibilities as pure information, as probabilities, and just render one single outcome into our virtual reality. It gets you the same result, but with incredible efficiency and elegance.
So let's bring it all home. The big takeaway here is this. The whole idea that our universe is impossible to simulate is only true if you make some very specific materialist assumptions from the get-go. If you open up to the idea of a non-physical computer, a larger consciousness system that uses probability instead of brute force, that whole argument just falls apart. It gives us an efficient way to render a complex reality without all the messy baggage and paradoxes of theories like many worlds.
And that leaves us with one last, pretty fascinating thought to chew on. If the objects and events in our world aren't solid, persistent things at all, but are instead just materialized into existence from a field of pure probability, right when they're needed, what does that say about the nature of reality itself? What exactly does it even mean for something to be real?